Hello everyone, hope you're all doing well, having a great time, and of course staying safe. This is class 9 science, chapter 12, section 1 and 2, and in this section we will try to talk about energy. Let's start. Energy and work. So we will start with energy. The first example we will take is the tennis player. For that person to play tennis, first she needs to toss the ball into air, then slam it with his racket. Then obviously the ball will fly towards his opponent, who obviously swings his racket at the ball. The ball goes into the net, causing it to shake, and this is how the match goes on. And now we will talk how each one of those players need energy to do the whole game. The tennis player needs energy to slam the ball with his racket. The ball also must have energy in order to cause the net to shake. Energy is around you all the time. Now we can answer the question, what is energy? Energy is the capacity to do work. So without energy, you cannot do work. Or you can say energy is the ability to do work. So energy enables you to do work. Now we can ask, what is work? In the previous lessons, you have learned about work. You already know work is a transfer of energy to an object by using a force that causes the object to move in the direction of the force. Remember when we said that work is done when a force causes an object to move in the direction of the force. How does the energy and work help you play tennis? This is the question. So, in another word, we will talk about how that player in front of you plays tennis. First, he applies force on his racket. Then the racket does work on the ball. And the ball does work on the net. This is how the energy is transferred. Basically, when an object does work on another object, energy is transferred from the first object to the second object. This actually allows the second object to do work. So work is transfer of energy. Like work, energy is expressed in the unit of joules, as you can see it in front of you. One more time, remember that energy is the capacity to do work. Moving on to kinetic energy. So in this part, we will try to learn about kinetic energy and what is kinetic energy. Let's take a tennis match as an example, or you can say a tennis as an example. So in a tennis game, the energy is transferred from the racket to the ball as the first player hit the ball. As it flies over the net, the ball has kinetic energy. So what is kinetic energy? Kinetic energy is the energy of an object that is due to an object's motion. Or you can say kinetic energy is the energy of motion. Basically, everything that is moving have kinetic energy. Like all forms of energy, kinetic energy can be used to do work. For example, the hammer and the nail in front of you. Basically, the kinetic energy allows the hammer to do work on a nail. How? Basically, when you swing a hammer, you give it kinetic energy, which does work on a nail. As you can see from the title, the kinetic energy depends on mass and speed. We have an equation that we can use to find kinetic energy. So the rule says, or the equation says, kinetic energy equals half mv squared. Now, as you can see in front of you, m is mass and the unit of mass is kilogram. V is velocity and the unit of velocity is meter per second. And you already know that kinetic energy, the unit of kinetic energy is joule. In your book, instead of velocity, it said speed. I'm pretty sure you remember that speed in a given direction is velocity. Let's ask ourselves a question. How kinetic energy depends on mass and speed? What is the relationship between mass and speed and kinetic energy? First, let's talk about speed. The faster something is moving, the more kinetic energy it has. This is about the speed. Second one, let's talk about the mass. The greater the mass of a moving object, the greater its kinetic energy. Now look at the example in front of you. We have a large car, a truck, and a motorcycle. Keep in your mind that these two objects are moving in the same speed. So they are moving 100 kilometers per hour. So they are moving in the same speed. We are talking about their mass. Their mass are different. So a large car has more kinetic energy than a small motorcycle. But let's go back to the equation. You remember that in the kinetic energy equation, the velocity or the speed is squared. So now we can say that the speed has a greater effect on kinetic energy than mass does. Now you understand the car crashes are much more dangerous at high speed than a car crash at lower speed. Why? The answer is very simple. Imagine a moving car has 4 times the kinetic energy of the same car going half the speed. Moving on to the potential energy. You know that kinetic energy is the energy of motion. What about potential energy? Potential energy, on the other hand, is the energy an object has because of its position. For example, the image in front of you shows a stretched bow. The stretched bow has potential energy. The bow has energy because work has been done to change its shape. So remember, because work has been done on it to change its shape, it has potential energy. The energy of the work is turned into potential energy. What happens before the archer shoots the arrow? The stored potential energy of the bow and the string allows them to work on the arrow when the string is released. Now, the minute the arrow is released, the arrow has kinetic energy because the arrow is in motion. What is potential energy? Potential energy is the energy that an object has because of its position, shape, or condition of the object. In this part, we will also talk about gravitational potential energy. So whenever you lift anything from the ground, you do work. You use force on that object you want to lift against the force of gravity. Now, this is important. When you do this, you transfer energy to the object and give the object gravitational potential energy. Let me give you another example. The book on the shelf have gravitational potential energy. And keep in your mind the amount of gravitational potential energy that an object has depends on 2 things. First, its weight. Second, its height. So the gravitational potential energy depends on two things. First, weight. Second, its height. So its weight and its height. Calculating potential energy or gravitational potential energy, or you can say GPE. You can find the gravitational potential energy by using the following equation. So basically GPE equals weight multiplied by height. And you also know weight is Newton, the unit of weight is Newton, and the unit of height is meter. We can say gravitational potential energy is expressed Newton meter, or you can say in joule. Let me explain why. You already know that work equals force multiplied by distance. What about weight? Weight is the amount of force that you must use on an object to lift. What about height? Height is the distance. So simply we can say gravitational potential energy equals to the amount of work done on an object to lift it certain distance. You can look at the red ball. When you drop it down to the ground from a height, let's say that the red ball, weighed 13 Newton, and the height up from the ball to the ground is 1.5 meter. What is the gravitational potential energy, or GPE? Basically, yes, 13 Newton multiplied by 1.5 meter, and the answer should be 19.5 Newton meter, or 19.5 joules. What if I told you, tell me the gravitational potential energy of an egg sitting on a kitchen counter? Probably you will tell me, this is very easy. I should know the weight of the egg and the height from the counter to the ground, right? What if I told you, you should find me the gravitational potential energy of an egg? There is several stories away from the ground. Now, in these both cases, the height tells you how far an object has to fall. The first case is probably a meter or so. The second case, it could be hundreds of meters. So, gravitational potential energy depends on point of view. Mechanical energy. What is mechanical energy? Mechanical energy is the amount of work an object can do because of the object kinetic and potential energy. Or you can say mechanical energy is the total energy of motion and position of an object, both potential and kinetic energy. Remember, the energy of motion is kinetic energy and position is potential energy. So just like we said, both potential energy and kinetic energy are kind of mechanical energy. Probably you will ask me, teacher, is mechanical energy should be both kinetic and potential energy together all the time? My answer will be mechanical energy can be all potential energy, or it could be all kinetic energy, or some of each. So it could be the combination of both. What is the equation that we use to find mechanical energy? Basically, mechanical energy is potential energy plus kinetic energy. Also keep in mind that mechanical energy of an object remains the same unless it transfers, moves some of its energy to another object. So does this mean that kinetic and potential energy stays the same And my answer will be, even if mechanical energy of an object is still the same, the potential energy or kinetic energy it has can increase or decrease. Look at the picture of the juggler. The juggler is doing work on the pin. How? Look at the picture in front of you. So basically what happens is he is moving the pin with one hand. So he is doing work on it. So the pin moves. And now the pin has kinetic energy. It goes up into the air and then its kinetic energy changes to potential energy. How can I tell that kinetic energy is decreasing? Well, you can see that the speed of the pins are slowing down as it moves upward. Now, keep in your mind that at some point, all the kinetic energy is transformed to potential energy. In this point, the pin is actually stopped moving upward. Then what happens? Well, the pin starts falling down. In this case, all the potential energy now is changing back to kinetic energy. Now I can tell that more potential energy is changing to kinetic energy. How? Because the speed of the pin is increasing. Then eventually it will fall down to the ground. Do we have any other forms of energy? Yes, energy could have other forms beside mechanical energy. These forms of energy include thermal energy, electrical energy, sound energy, and they are forms of kinetic energy. Of course, we will learn about them later on, but what about potential energy? Do we have examples of or forms of potential energy? Of course, we have. So, light, nuclear, and chemical energies, they are forms of potential energy. Let's say you have a book on a table or a mug or anything on a table. As long as the object is on a table, it has gravitational potential energy. Good job. What about if the mug or a book or the object fall down to the ground? Its potential energy change into kinetic energy. This change is an example of energy conversion. So what is energy conversion? Energy conversion, as you can understand from the example, is a change from one form of energy to another. So at first the mug or the book had gravitational potential energy. When it was about to fall down or it fell down to the ground, it changed to kinetic energy. So one form of energy changed to another. So energy conversion is a change from one form of energy to another. Keep in your mind that often one forms of energy change into more than one other form. Look at the picture in front of you. Can you understand when the skateboarder has potential energy and when the skateboarder has kinetic energy? Let's talk about the point where the skateboarder gets up so high in the air. Of course, before this point, the skateboarder was moving at high speed on his way up the half pipe, right? Before he goes up into the air, he had a lot of kinetic energy. What had happened to the energy? His kinetic energy changed into potential energy. So as you can see in front of you, in the high in the air, the skateboarder has a lot of potential energy. What will happen if the skateboarder start moving once again? Well, obviously, the skateboarder potential energy will become kinetic energy once again as he speeds down the side of the half pipe. And keep in your mind, as he speeds down through the bottom of the half pipe, the skateboarder kinetic energy is at maximum. Elastic potential energy. The first example, we will talk about the slingshot. Do you know that the rubber that is used in a slingshot can actually store energy? The type of the energy that is stored in a slingshot is, in the rubber of a slingshot, is elastic potential energy. When the rubber band is let go, the stored energy becomes kinetic energy. And you can actually use it to throw a rock. Now, I'm not telling you to do it, but it is a very fun experience, and very dangerous situation could happen from it. Do you know what else can you do with a rubber band? You can actually change the shape of a rubber band by stretching it. The energy you put into stretching it becomes elastic potential energy. The rubber band and the skateboarder are very similar. Tell me how. Well, since you ask, I'm going to answer you. Like a skateboarder, at the top of the half pipe, the stretched rubber band stores potential energy. So when you stretch a rubber band, the rubber band stores potential energy. When you let go, it releases the stored potential energy into kinetic energy. And conversion involves chemical energy. What is the chemical energy? Whenever you eat food, you get chemical energy. Breakfast is very, very important meal of the day. So basically, you eat food. This food is used by your body to get chemical energy. Your body uses chemical energy to function. Let me ask you a question. Why energy conversion are important? The answer is very simple. We use energy conversion in everything. Heating our homes, getting energy from a meal, and many, many other things use energy conversion. Let's take an air dryer as an example. An air dryer changes electrical energy into thermal energy. So electrical energy enters the air dryer and converted into kinetic energy as small electric motor spins a fan blade. In the second step, as you can see, electrical energy is also converted into thermal energy in a grid of wires that heats up. The third step is the following. The fan focuses air across a hot wires and hot air blows out of the nozzle of the hairdryer. You can hear the sound of energy that also comes out. So we have two kinds of energy, sound energy and thermal energy, and we use electrical energy in the same machine. We are using electrical energy everywhere, all the time. You listen to the radio, or when you're taking a picture, or you're using electrical energy. Electrical energy can easily be changed into other forms of energy. Let's take an alarm as an example. So in an alarm, electrical energy is changed to sound energy. What about in a battery? A battery chemical energy is changed to electrical energy. What about a light bulb? In a light bulb, electrical energy is changed to light energy and thermal energy. Electrical energy in a blender is changed to kinetic and sound energy. Okay, we reached the end of this part. Thank you for your time and thank you for your attention. And your homework will be the review in page 211. And good luck.